Now we're going to take a look at a quartic function. And I know it's quartic because it looks like a W. And the end behavior is pointing up in both directions, which means I'm going to have a positive a value, and it's going to be a fourth degree, but even degree. Okay, so my job is to identify that both of these x-intercepts are bounce-offs, which can't come from even degree factors, even multiplicity on my roots. So this -4 came from an x plus 4, and then you put a squared on it to give it an even multiplicity of this root. And then we do the same thing over here at this 5. This is x minus 5, and then we just say squared because it's bouncing off. Anytime it's bouncing off, we have even degree on my factor. So I just put those together with an a value. I don't know what a is yet, so I'm going to call this f of x is a, I just know that it's positive, times x plus 4 squared times x minus 5 squared. With this information, I'll be able to identify what the function is that is graphed here simply by using my y-intercept. The y-intercept is 0, comma, I don't know. I got to actually look pretty closely. It looks like I'm counting by 20s, so that's 80, so that's going to be 100 there. So 0, comma, 100. And so that means f of 0 is 100. So that's equal to my function here where I plug in 0. So I'm going to say a times 0 plus 4 squared times 0 minus 5 squared. And now I just have to work through solving for a. Careful, these are squared. So we've got 16. So a times 16 times 25. The -5 squared is still positive 25 equals 100. So we figure out what 16 times 25 is. So we should get 400. A equals 100. And then you divide both sides by 400. And you get a is positive 1/4. Once I figure out what my a is, I just have to put it, replace it right there. So f of x is 1/4 times x plus 4 squared times x minus 5 squared.